Hello everyone. Today we're talking about variables and equations, and this is from lesson 1-5 in our book on page 28. You're more than welcome to follow along in your book if you'd like to. For this lesson you will need a pencil and a highlighter, so go ahead and pause the video now if you need to go get those things. Let's begin by going over a few definitions that you'll need to know. The first one is equation. And an equation is a mathematical sentence that contains an equal sign. And just in case you forget, the equal sign looks like that. Pretty simple. That's the definition of an equation. And then an open sentence, it's not like a written sentence that we use in an English class. An open sentence is a type of equation that contains a variable. Go ahead and fill those two things in on your notes right now. All right, and then in case you forget, a variable, this is in section 1.3, but a variable is a placeholder for any number. Or I like to say that it represents an unknown number. So if you forgot what a variable is, you can go ahead and write that down as well. I will be talking a lot about variables and equations in this lesson, so make sure that you have those written down so you know what I'm talking about. All right, so let's go ahead and look at example 1 at the bottom of page 28. I've typed it on the screen in case you don't have your book with you. So this is an example of an equation. It has an equal sign. And this one is also an open sentence because it has a variable. In this case, m is our variable. We don't know what m equals. We don't know what that number is. But we have this chart down here that we're going to use to try to determine what m is. So on this column right here, it says value for m. All that means is we're going to take the values that they have given us and try to plug them in for m to see if this makes the equation true. For example, if this right here is a 1, we would take the 1 and we plug it in for m up here, and it would look like this. We would do 12 minus 1, because we put the 1 in for m, equals 8. And then we ask ourselves, is that true? Well, do you know that 12 take away 1 is 8, or is it not 8? It is not 8, so that way, in this case, the answer is false for 1. We're going to work through these ones together for numbers 2, 4, and 7. So let's go ahead and do that now. Okay, so our first value is right here. It's a 2. And we're going to plug that in right here to this m. So that would look like 12 minus 2 equals 8. Well, I can ask myself now, is that true? 12 take away 2 is 8? No, that's 10. So my answer over here is false. Let's look at 4. So we take the same equation from up here, and we do 12 take away 4, oops, not 44, equals 8. Is this equation true? 12 take away 4 is 8? Yes, it is. This is true, so we could write true in this line. And then let's look at 7. 12 take away 7 equals 8. Is this equation down here true? No, this is not, so the answer is false. Let's go ahead and try the number 9 in here. And you can at home fill in this blank right here, what it would look like. Oops. And then tell me if that is true or false. So go ahead and fill in this box and this box right here. Go ahead and pause the video if you need a moment to do that, and then we can move on. Now that you've finished your row right here for 9, we can write out our final answer. We can say the solution for 12 minus m equals 8 is, in fact, 4, because this row was the only row where the equation read as a true statement. 12 take away 4 is 8, so that way the solution for M is 4. Let's continue and move on to example 2. Now in the book, your demonstration, they do it just a little bit differently, but for mine, I'm going to use this same chart up here because I think that's really helpful when we're solving these kinds of problems. So this example 2 asks us to find the solution of 2x plus 1 equals 7. Now, when you have a number right next to a variable, please remember that always means to multiply. So in this case, they're asking us to use a 6 first. So we're going to do 2. And if you forget that a multiply, you can use a dot or you can use a little multiplication sign like this. But I like to use parentheses because that tells me that I'm multiplying as well. And it shows me exactly where I put my variable in. So here's my variable and there's my parentheses. So I did 2 parentheses 6 parentheses plus 1 equals 7. Now with this one, you're going to have to do a little bit of math as you think about it. You're going to have to think, well, 2 times 6 equals 12. And then I have to add 1 to it, so plus 1 equals 13. And then you're asking yourself, does 7 equal 13? Well, the answer there is no, so your answer over here is false. Let's do the next one together. 2x plus 1 equals 7. In here, we're replacing the x with a 4. So we're doing 2 parentheses, oops, wrong column. We're doing 2 parentheses 4 plus 1 equals 7. And let's try it. We know that 2 times 4 is 8 plus 1 equals 9. Does 7 equal 9? No, it does not. So the answer over here is also false. Go ahead and try 3 on your own. We'll set up the problem together and you can solve it. 2, we're replacing the x with a 3. So 2 parentheses 3 plus 1 equals 7. Now you solve it right here and tell me if you think that's true or false by writing true or false in this box. Go ahead and pause the video so you have time to work on that. Okay, so if you finished solving it, that's excellent. Let's do it together now. 2 times 3 is 6, plus 1 equals 7. Does 7 equal 7? Yes, it does. So we've now found the solution. This column would be a true column right here. And then we would write underneath that the solution of 2x plus 1 equals 7 is, what did we decide it was? We decided that it was 3. There's our answer. So let's move on to one more example that's actually not in your book. And this one is an example of a variable in an equation that you can solve just by thinking about it. So this one you don't need very much work for, which I think you guys will like. So we have 6x equals 30. Now go ahead and think about it in your mind for just a little bit. Is there a number, because remember this means multiply, is there a number that you know can be multiplied to 6 to get to 30? In other words, what times 6 is 30? Think about it in your mind and write it down in this space right here if you think about it. If you've got it, your answer should be 5 because we know that 6 times 5 equals 30. So in this case, what would x equal? You just showed me if you decided that it was 5. X equals 5. So this is a different way to think about how to solve for a variable if you're solving it mentally. Some of these equations are pretty simple to think about. All right, for our last example for this lesson, we are going to be looking at example 5 on page 30. And before we get into this example, I want you to think to yourself for a little bit about all of those words that we brainstormed in class last week about what it means when words tell us to add, subtract, multiply, or divide. For example, if we see the word more, that means that we're going to be adding. If we see the word less than, that means subtracting, things like that. So keep that in mind as we go into example 5 right here on page 30. And example 5 gives us words that we need to change into an expression. So it's going to look a little bit different than what you're used to seeing, but follow along with me. It's the difference of a number and 10 is 17. Okay, so let's break this number or this word expression apart and then we can get it into numbers. So the difference, we know that the difference tells us to automatically subtract. So we know that we'll be subtracting something. And then we have a number. So a number is the same, what you'll see when you need a variable, because it doesn't tell us which number, it just tells us that there's some sort of number that goes here. So we'll need some number, which we can represent with any letter of the alphabet that you like to. I typically use N. And then it says that number and 10. So we've got a number right here, that's perfect, we've got a 10. And then this is a word that we haven't worked with very often, but is always means equal. So if you ever see an is, that will mean an equal. And then here's 17, we've just got another number over here. So let's break this up. We've got the difference, which we decided means subtraction. And then we've got of a number, so we've got an n. And we've got, oops, a little too far. We've got a 10. And we've got is 17. So now we've got this is 17 part down. We just need to figure out this, because this right here is not an equation. It's not the way we are used to seeing an equation. So the way we have to write it is the difference of a number and 10 is 17. So go ahead and look at this. Do we have all of the pieces that we had up in this row? We have an n for our number right here. We have difference, which is the subtraction right here. And we have a 10 right here, which was also in our equation up here. And then we have is 17. And here's our is 17 up in the original problem. So believe it or not, this is actually your final answer. You wouldn't have to do anything else to that problem if you're doing a problem like that in the book. Okay, so go ahead and take a minute to look at this. We'll do one more example before the video ends. For our last example, it's going to be just like the one above where we're changing words into an expression. This time we have a different function though. Remember, a function is just what tells us to add, subtract, multiply, or divide. So this one says a number times 3 is 45. So we know that we have a number and we have a 3 and we have an is 45. But typically we need some sort of symbol between when we've got numbers on this side, either an addition, subtraction, multiplication, or division sign. And for this one, we're multiplying because it says times right here, a number times 3. So you can either write it as 3 with the multiplication symbol and an n equals 45, just like that. But what do you see that could be confusing about this? Sometimes this multiplication sign looks like an x that's also in a variable. And we don't want to be confusing on that. So sometimes people use a dot, and I don't have a dot on my computer, but I can do this to kind of show you. Or with multiplication, you can also just squish those numbers together. So you can do 3n equals 45, and then this would be your final answer. All right, and then lastly, here's your quiz that you'll need to complete at home. Make sure you do it on a separate piece of paper to keep in your quiz section of your binder. And then at the bottom of your quiz or somewhere on your quiz, write red, yellow, or green to tell me how you feel about this new information. Red is I'm confused and need help. Yellow is I think I get it, but I need practice. And green is this is way too easy. I totally understand it. I'm ready for a challenge. So write red, yellow, or green somewhere on your quiz after you solve it. Go ahead and pause the video now because it's just about to end so you can finish this quiz. Good luck, and I'll see you in class soon.